Jenny. I heard there's gonna be some great waves next week. You wanna go surfing?
Yeah, I wanna go.
But wait, we don't know how to surf. How are we gonna learn how to surf in such short time?
I don't know.
Hey Jenny, will you look at that?
Yeah!
Surfing class! Woo! Let's go!
Alright,
Learn some surfing!
Woo!
Right. Hello!
Alright, dudettes, are you ready to catch some gnarly waves?
Oh, you know it!
Woo! Well, before you get to hit the beach, we're going to make sure you understand the physics behind the most important aspect of surfing, ocean waves.
What are you saying?
You'll see. Just hold on to your seahorses. The size and energy of a wave depends on three things. The time, how long the wind has been blowing, the strength of the wind, and the fetch, which is how far the wave has traveled. Different kinds of waves that you might encounter while surfing would be either constructive or destructive waves. When the wave breaks, the water that is washed up on the shore is called the swash, and the water that is washed back down is called a backwash. In a constructive wave, the swash is greater than the backwash. They are characterized by calm weather, are less powerful, and build up beaches. They have long wavelengths, a low height, and a low frequency. In a destructive wave, on the other hand, the backwash is greater than the swash. They are created in storm conditions and are very powerful waves that are there for a long amount of time. They erode the coast and are characterized by a short wavelength, a high height, and a high frequency. Make sure you watch out for these kind of waves when you're surfing. Any questions? Well, I'll take that as a no. Shall we move on to the speeds of shallow and deep water waves? I think we shall. In shallow water waves, this is the equation to find the speed, where the speed, c, equals the square root of gravity, g, times the depth of the water, h. We see that for a wave in water with a depth of 3 meters, the speed would equal approximately 5.42 meters per second. Moving on to deep water waves, eyeballs, eyeballs, eyeballs.
Oh, what?
C once again represents the speeds of waves. However, in this case, the speed equals the square root of the quantity gravity, g, times wavelength, L, divided by 2 pi. If the wavelength equals 490 meters, the speed will equal 27.64 meters per second. Does everyone see how that equation works? Good. Now something else to note when discussing ocean waves is that they are still, in fact, waves. Water molecules are actually not moving very far. It is the energy moving through the medium, which is the water molecules. The waves you will be catching are mostly caused by ocean currents. A current is like a vast river in the ocean flowing from one place to another. These currents are caused by differences in temperature, difference in salinity, and by wind. Currents are responsible for a vast amount of movement in the water found in oceans, the Earth's oceans. That concludes today's introduction to the physics of surfing for dummies. Thank you for coming, and we hope to see you again next week, or to be more Pacific, on Saturday.
That lecture was so boring. I think I just tied.
I know, right? If I have to learn any more of this, I have to krill myself. Let's get out of here.
Alright.
Welcome back, class. Today we're going to be talking about ocean currents. Oh. Why have you done this to me?
What happened, you all?
What are you doing?
Oh, we got hurt while surfing. Ow, my arm.
You got hurt while surfing. You know there was a hurricane, right?
A what?
A hurricane. Maybe if you'd be paying attention during class, you would have heard our lecture.
Destructive waves are the worst time to go surfing.
Duh.
I thought we were in Chinese